Morning Year 10. Today we're looking at another required practical, making a salt from metal carbonate. 5 learning outcomes today. The top 3 are all for the foundation and the higher, whereas the bottom 2 are only just for the higher. And there is a lot of safety that goes into this practical, lots of emphasis on techniques and practical understanding of why we do different things at each stage. We do need to be able to do the word equations and balance them, as well as naming the acids, the metal salts that are made from different acids. For the higher, you do need to be able to balance those equations and understand that this is a neutralization reaction and predicting products given acids and bases and the right appropriate equations. So let's move on. So again, as always, the Caboodle textbook will support you with this. So page 78, 79 in the chemistry trilogy, for those of you who are preferring to work through the textbook or would like some additional information. So key facts of making salts. So when we react a metal with an acid, we talk about this becoming an insoluble substance, and therefore the metal bases such as metals and metal oxides or hydroxides or carbonates, these then become a liquid, go from solid to being within the liquid, and we call this a neutralization reaction. The carbonates which react produce the corresponding salt, and they produce water and carbon dioxide. Metal oxides react with acids to produce corresponding salt and water. And this practical specifically looks at how to produce and prepare safely a salt by reacting sulfuric acid with either copper carbonate or magnesium carbonate. Okay, and there's some key terminology. And I would suggest, if you're not 100% clear on these, that you have these written down. So solvent, solution, neutralization, solute, and insoluble. And these, again, on the foundation paper are often those matchy sort of statement questions where they want to see how much you understand. So the equipment. We have several parts to this equipment. So first of all, we've got our first picture, which has got my glass rod, beaker, metal and acid and carbonate. And what we would be expecting to happen there is some stirring to try and get as much of that reaction to occur as possible and increase contact between the reactants. Then what we have in the second picture is a filtration setup, and we've got a funnel and filter paper, and that will filter any solids out of the liquid. So that will filter out any excess solids that have not been reacted. And the third picture is where we've got a Bunsen burner heating with like a water bath on top, heating the solution of metal sulfate or metal chloride. And that was to remove any of the water that has been produced during the reaction. Now you'll notice on the side we have put down the equipment list, and this is one of the ones that they often ask you, how would you do this practical for a 6 marker? We've also listed the reactants and the fact that some of these are irritants. And first of all, I want you to just think about what safety you would include and why. So just pause the slide now and write down your safety tips. Right, so what did you get? You have to check the CLEAPS cards and the fact that these are all the different things that could happen with the risk assessment. And you can say that if they're irritant, it irritates skin and eyes. And how would you reduce that risk? You need to include a mention of safety goggles. You may want to talk about clearing up spills. Then you need to talk about toxic, make sure your hands are clean afterwards. Glassware breakages, risk of being cut. So again, making sure that you clear any broken glass and dispose of safely. And lastly, Bunsen burner and burns. So we're going to make sure that we avoid touching hot things and reduce our risk. The idea with the risk assessment is not that you don't do the practical. The idea is that you reduce those risks to a minimum. So there is still the risk that something could splash in your face. However, the damage would be caused if it hits your eyes. Therefore, what we then do is wear safety goggles. and then everything else can be wiped off immediately, and making sure we're washing our hands. So, reducing the risks. This is the perfect answer. Okay? Take a minute just to write those down. So this is the method. I suggest that you write up this method and make sure that you, again, especially if you're doing the foundation, that you have drawn these diagrams and labelled them nice and clearly so that you've got them. Okay? Right. So there are 2 YouTube videos for you to watch this practical be carried out. We're not going to do this in school. However, you will get a chance to do it if you haven't already done it with your class teacher when you return. So, watching the videos, see if you can answer these 4 questions. Okay. So, complete the word equation and simple equations for the neutralisation of metal carbonates. And copper sulfate is made by reacting copper carbonate with sulfuric acid. So we know that the salt that's being made will be a sulfate. All right. So therefore we get copper sulfate, so the metal salt. So we take the copper, which is the metal, and the name of the acid, and we make that out of it. Because it was a carbonate, we know that it produces carbon dioxide and water. So the simple equation for this reaction is, and that's balanced for you. And then write the word equation for magnesium sulfate by reacting magnesium carbonate with sulfuric acid. So again, we know that it's magnesium sulfate, water and carbon dioxide. These are all exam questions, and you'll be getting 2 marks for each correct line. Write the simple equation for this reaction. And there again it is perfectly balanced. Word equation for copper chloride made by copper carbonate with hydrochloric acid. Because it's hydrochloric acid, we know it's a chloride salt, and it becomes copper chloride. Complete the simple equation for this reaction. And again, there you are, perfectly balanced. So some exam questions. Pause the slide now and see if you can do this. And you can see here at the bottom, it's a nice 6 marker based purely on what was given for this activity. And here are the answers. So the perfect test for CO2 is lime water, and it turns it cloudy/milky. And then what we've got here is the method that they're expecting. Okay. Lastly, we're looking at the skills gained during this practical, and you need to be able to show understanding of a range of techniques, including filtration and evaporation, and describe them, plus suitable apparatus, plus risk assessing. And lastly, have a regard for accuracy of measuring reactants, main hazards, and suggest methods of reducing them.